Hello friends, grab your coffee, grab your cookie, and today please keep both far away from any boiler stack or sulfur-smelling exhaust because we are talking about sulfur dioxide, the gas that loves combustion, hates clean air, and turns into acid the moment it meets moisture. I am Michael Klepik, and for more than 15 years I have been designing gas cleaning systems for power plants, smelters, refineries, and chemical facilities. Today I want to explain how SO2 scrubbers work and why sulfur control is never optional. What SO2 really is. Technical description. Sulfur dioxide is an acidic gas formed when sulfur-containing fuels or materials are burned. In simple terms, first, sulfur in fuel oxidizes during combustion. Second, sulfur dioxide forms in the exhaust gas. Third, the gas is highly soluble in water. Fourth, it reacts easily with alkaline solutions. Fifth, it converts into sulfurous and sulfuric acids. This makes SO2 chemically easy to scrub, but mechanically demanding. Where SO2 emissions come from. SO2 emissions are common in first, coal-fired power plants, second, oil and gas combustion systems, third, metal smelters and roasting furnaces, fourth, sulfuric acid production, fifth, refineries and petrochemical plants, sixth, waste incinerators, seventh, marine and industrial boilers. Anywhere sulfur is present, SO2 follows. Why SO2 is a serious problem? Sulfur dioxide creates several major risks. First, it forms acid rain. Second, it causes severe respiratory irritation. Third, it corrodes steel and concrete. Fourth, it damages downstream equipment. Fifth, it triggers strict environmental regulations. SO2 is visible, measurable, and heavily regulated. How SO2 scrubber systems work. SO2 scrubbers rely on absorption and neutralization. First, hot exhaust gas enters the scrubber. Second, gas contacts an alkaline liquid. Third, SO2 dissolves rapidly into the liquid film. Fourth, chemical neutralization occurs. Fifth, clean gas exits the system. The chemistry is fast. The challenge is handling volume and corrosion. Behavior of SO2. Inside the scrubber. Inside the scrubber, first, higher liquid pH increases removal efficiency. Second, lower gas temperature improves absorption. Third, good liquid distribution is critical. Fourth, solids formation must be controlled. Fifth, mist carryover must be minimized. Poor internal design leads to acid breakthrough and corrosion. Torch air SO2 scrubber technologies. Torch air designs. SO2 scrubbers using several proven configurations. Packed bed SO2 scrubber used for high efficiency sulfur dioxide removal. Tray type scrubber used for large gas volumes and dirty exhaust. Venturi plus packed bed systems used when particulate and SO2 are present together. Flue gas desulfurization systems used for power plants and large combustion sources. A scrubber is not just a tower, it is a controlled chemical process. Regulations and compliance. SO2 control is regulated under, first, EPA sulfur dioxide emission limits, second, state and local air permits, third, power plant emission standards, fourth, industrial combustion regulations, fifth, occupational exposure limits. Failure to control SO2 almost always leads to enforcement action. SO2 scrubber system design considerations. When I design a complete SO2 scrubber system, I always include, first, alkaline reagent selection such as caustic or limestone slurry. Second, corrosion-resistant materials like FRP or line steel. Third, differential pressure monitoring across scrubber internals. Fourth, high-efficiency mist eliminators to prevent acid carryover. Fifth, slurry or liquid solids management. Sixth, automatic pH and flow control. Seventh, proper fan placement to avoid sulfuric acid corrosion. Without these elements, SO2 scrubbers fail early and expensively. An SO2 scrubber is one of the most proven and effective air pollution control systems in industrial history. When designed correctly, it removes sulfur dioxide efficiently, protects equipment, and keeps facilities compliant with some of the strictest air regulations on the planet. I am Michael Klepik. Protect your air, protect your equipment, and remember, sulfur belongs in chemistry, not in your exhaust stack. See you in the next video.